Welcome to the Databricks Skill Builder series. We're glad you're here.
Started. So we are recording this webinar. We'll send it out after you. Thank you to everyone for coming. My name is Dallas Swift. I'm a solution architect here at Databricks. And I'm here to introduce David Lyle, who's going to be discussing UDFs with Delta Live Tables. Thank you everyone for coming. Some quick bookkeeping here. If you have a question, feel free to use along the bottom. There's a Q&A section, a Q&A chat. So you're welcome to type anything in there, and we will answer questions throughout the presentation. And also feel free to raise your hand in the participant list. I'll see you with your hand raised. And if you want to ask questions verbally, that's also available to you as well. And with that, thank you again for coming, and I'll turn it over to David.
Hey, good afternoon, everybody. First of all, Dallas, is my screen coming through okay, and can you hear me okay?
Yes.
Excellent. So 2 for 2. So just kind of before we get started, I want to make sure that we're kind of navigating the initials okay. We're talking about Delta Live Tables and using Delta Live Tables with UDFs, which is pretty much something we've been doing for a while, using non-Unity catalog tables. But now we're actually in a preview to do it with Unity catalog. And I kind of wanted to give a preview of coming attractions and maybe create a motivating example to see how it works. It's an architecture that I've been deploying fairly a lot lately in customer environments, everything from XML parsing, which you're going to see today, to actually full computer vision and machine learning algorithms. So before I dive right in, a little about me. So I'm what they call a specialist solutions architect, and what that means is, in my vertical of usually manufacturing, we kind of do the solutions architecture work for the solutions architects. So perhaps Dallas will be working hard with a customer trying to realize some of their use cases, and maybe we need to deep dive on a topic. And my thing, although I come from computer vision machine learning background, because I come from it from a perspective where you have to do data engineering to be successful in computer vision and machine learning, I've actually gotten pretty good at data engineering as well. And lately with DLT, that's made my life really, really easy. So just know about me, I've been bouncing around the open source community for quite a while, came up through Hadoop and Cumulus, Spark, and Solar, turned on to Databricks about 10 years ago, and have not looked back. When I'm not crunching code, I'm roller skating or brewing beer or hanging out with my big dog Riley, who is about 110 pounds of fun up there in the top right-hand corner. What we're going to do today is we're going to talk a little bit about Delta Live Tables and what they're doing with it and how to use it for data engineering, touch on best practices, but then what I really want to do is just kind of get through a demo. And I have a couple of notebooks and a few pipelines to show. And my hope is, particularly as there's 10 or under on the call right now, please do feel free to ask questions either in the chat or raise your hand and get unmuted. And I think the most valuable presentations that I've been a participant in, as well as a presenter on, are the ones that are interactive. So don't hesitate to, hey, let's double click on this, or you're boring me, let's move on. I'm receptive to all that kind of feedback. And there'll also be a little bit of time for Q&A at the end, but again, hopefully we'll get it as it goes. So just to kind of orient everyone, what we're talking about is actually building a proper data lakehouse. And the foundation of it from a Databricks perspective, and really kind of universally right now, is we're using Delta Lake. So Delta Lake, as we all probably recall, added a ACID transaction layer to the Parquet data format. And what that does is that really created an opportunity to solve a lot of problems that Parquet had in terms of transactionality and side effects being written to your table, so you never knew what was real data or what was data that was in process but maybe didn't get processed quite right. So that's really what the base layer of your well-architected lakehouse is going to look like. And the cool thing about Delta is it's open and it's community driven. So it's out there on GitHub. It's licensed and maintained by the Linux Foundation. There's a public roadmap, and everyone can contribute to it, and there are community events and office hours. And right now we're at 9 million monthly downloads. That might be a little low. I think it's gotten better, but yeah, definitely 7K on Slack. So it de-risks your investment, right? So you want to use Delta, use Delta. I prefer you did it on Databricks, but maybe you want to use it in the open source version, or maybe you want to use it with one of our partner vendors. That's fantastic. The important thing is Delta is going to keep you open, And it's going to connect to most of the things that you're currently using. See, at the center of the data lakehouse world, you have your Delta Lake, but then there are all these other, animals in the zoo, we like to call them. And we, as Delta, kind of connect seamlessly with those other applications. It also performs really well. So if you notice, and in this benchmark, the larger line is better. We're kind of outperforming the other storage formats that we've been looking at, and hope to continue to do so. So a constant innovation and things of that nature. And then of course we need governance. So one of the problems with a data lake house was everything was everywhere and there was no governance. So you really had to create these silos of data to keep people able to access the things they needed to access to perform their function, but unable to access things they shouldn't be accessing. Unity Catalog kind of solutions that. So all the data lands in the data lakehouse, and through Delta Lake and Unity Catalog, that's how we're able to provide that governance layer that you're going to need in your well-protected lakehouse. And how it used to be, it was pretty complex. You'd have to do it through a bunch of different techniques and applications, and we've unified that. And that's kind of where we are on that. But what really we wanted to talk about today was data engineering. So as our destination for all of our data becomes the data lakehouse, we need a really easy to use model of realizing our ETL. And it needs to be accessible in languages that people are comfortable using. So we've chosen Python and SQL. And wherever you are in your data journey, SQL will probably be a good place to start, and certainly Python. So we figure we have 80 to 90% of the cases covered just by covering those two languages in our declarative framework. We firmly believe that the best data engineering platform is a lakehouse, and here's why. So we're going to put all of the data in trillions of rows processed from thousands of sources. And then here there's Kafka and Kinesis, your normal CSVs, JSON, and text. Today we're going to be talking a lot about XML, and we have this pattern of elaboration we call medallion architecture. And really what we used to call that was progressive elaboration or a multi-hop architecture, but the notion is the same, and that's we have a bronze layer. So the bronze layer is kind of special because it exhibits what I would call data lake semantics. That is, you just throw everything into your bronze table as fast as you can with little transformation and little thought to concerns of imposing a schema upon it. So it will have a very lightweight schema. In our example, it's going to be the metadata about when it was collected, the file name where it was stored prior to us getting it, and the actual content in the binary object. From there, the pipeline moves through what's called a silver set of tables. And this is the filter, cleaned, and augmented data. So this is where you actually do data transformations, for example, to orthorectified imagery or images to stereo depth maps or things of that nature. In our example, it's going to be XML binary objects into JSON because I just find it easier to work with JSON. So my first activity is getting it to something I find easier to work with. And then we have a set of gold tables, and these are our business level aggregates. So they could be features for data science and machine learning. They could be KPI rollups. If you're doing a change data capture use case from something like Salesforce, your streaming analytics would likely land there in the form of aggregates. And throughout all of that, of course, we offer observability and monitoring, data reliability, and governance. Delta Live Table kind of unlocks all of that for us because we've landed on a standard pattern. So we do data ingest through autoloader. And if we go back to all of the animals in the zoo, autoloader can address all of those sources. So Delta, Parquet, raw tables, Kinesis, Kafka, Event Hub, really doesn't matter. Most of the things that you're going to want to see ingested into your data lakehouse are going to be supported by autoloader. So we realize the bronze table using autoloader or copy into if you don't get any new data. And then we transform them using Delta Live tables for batch and streaming data. And an important takeaway from this whole architectural part of the discussion is there's no difference. Batch data is simply streaming data that runs at a different triggering cadence. And what I mean by that is it's exactly the same Delta Live table code, and it's exactly the same set of transformations. And if you've been at this a while, you might have had an experience with a Lambda architecture or some batch streaming hybrid architecture prior to Spark and Databricks, where you actually have to maintain different code for your batch semantics and your streaming semantics. And that created problems of fidelity of data. That is, the code would diverge and you'd get different answers depending on where the data arrived. And that all goes away now that we've landed on a common declarative realization for the Delta Live tables, regardless of whether it's batch or streaming. And I'll point out exactly in the demo how one is how batch is streaming and how streaming is batch. Any questions on that so far? I didn't see any hand goes up, but there was a lot of there. No, okay. So again, good data is the foundation. So in our framework, we need to be able to impose constraints in our data. Certainly in bronze, we're probably going to take it all in with very few constraints. But as we move through this multi-hop medallion architecture and we get less data lake-like and more data warehouse-like, and that's the magic, right? On the left, we have kind of data lake semantics. On the right, we have data warehouse semantics. In the middle, it's kind of in between, and that's the lake house. Quality improves, but also schema enforcement is more rigid toward gold, and constraints begin to be introduced in silver and gold. And you didn't used to be able to do that. Other frameworks don't really let you do that. You have to run through different pipelines for different types of data. DLT abstracts all of that from you. So, we can combine all of these and still maintain an open standard to allow us to use Glue or Datadog or CloudWatch where it's important, but unify our data ingest pipeline. So it's one set of code, easily promotable through your CI/CD process. And by way of an example, there's a talk that was given at Summit a couple months back now, I guess, from John Deere, subsidiary called BRT, and they went from having an idea being presented in architecture for their computer vision image processing pipeline and realizing it in production in less than 3 weeks with 3 engineers. Now, that's kind of the abilities that you get when you use Delta Live tables. And this is what it looks like. So rather than run a SQL query to create a table, you write a SQL query to describe a table. And it's always kind of create as select. So in this case, we're creating a streaming table as select from cloud files. So that's the autoloader. Or maybe creating a materialized view from select from this raw data table. And what that does is that accelerates our ETL development. Our SQL and Python automatically orchestrates the graph. So your workflow graph is orchestrated for you. Retries happen automatically, and changing data can be evolved in the autoloader automatically. Infrastructure management is no longer something we need to be concerned about. You tell the pipeline when you instantiate it, I want to auto-scale between N and K nodes, and it does that. And recovery happens automatically and things of that nature. And we ensure that high data quality that we need because we have built-in quality controls in the form of constraints. And we have testing, monitoring, enforcement. And of course, we unify batch and streaming. There's no different code base. It's one single unified API, one single set of code. You can create a monitoring table. Each individual pipeline has its own built-in monitoring, and we can roll all that up in DB SQL to a view like this, showing exactly how many records are taking in a day, how many are failing, what the quality of our data is at any slice of time. We can also couple this with workflows, and this is where it gets really powerful because you'll notice if you look really, really closely at this eye chart, and I apologize for the size of the text, this isn't just workflows and this isn't just DLT. It's a workflow consisting of tasks that are sometimes realized by DLT, sometimes realized by straight up Python wheels, and sometimes realized by a combination thereof, like when we're doing inference and things of that nature. So this lets us handle all of that in a fully managed way. And to kind of drill into that example, you'll see in an example workflow, we began with DLT. So everything that comes in, and this is a quick stream monitoring use case, we handle with DLT. And then as we start refining the data, as we start funneling through it, maybe we do a match with DLT, maybe we do it in SQL and Python. We're going to build features. So, okay, now we're using MLflow. If we want to, we can maintain that in DLT, but perhaps we have a legacy or we want to use a different set of tooling. That's fine. It integrates seamlessly. In and out of DLT doesn't make a difference. And of course, you persist and train your model. So that's the whole data lakehouse vision. And then I wanted to kind of just take a second to pause on the open standards. So it's not just a Databricks vision, and it's not just an open source Delta Lake vision. It's shared by Microsoft and Capgemini as an implementation partner, and H2O is using MLflow and things of that nature. So we have a very rich ecosystem where you can use the tools you want to use on the foundational data platform, which is your data lakehouse. Before we dive right into the demo, a couple of best practices on DLT. So thing one, decide between continuous or scheduled data ingestion. And the good news is you can make a different decision tomorrow. So this is just how you realize an autoloader table. And we can do schema evolution on all of these file types as they come in. And we today can run it as batch. And that's what we're going to see today. I'm going to run it trigger once and be done. But you can run it continuously. You can run it on a hourly cadence, however you want. Make sure that we're using intent-driven declarative development. So again, we're saying what we're solving, not how we're doing it. Notice I'm not really giving Databricks any hints about what I'm doing. I'm just saying, hey, create this table. This is where your data comes from, and it's CSV. And then we just move on through the pipeline. So now we're going to select from account raw to create the bronze table. We're going to create another silver table from accounts bronze, and on and on and on. In this, we can also check for syntax errors and things of that nature. It's just a really rapid development environment, and it supports change data capture. So very common use cases is we're pulling in CDC from your Salesforce system or whatever else you're using for ERP rather, and absolutely fine to do that. We do SCD2. Apply changes into, and even out of order events can be handled with Delta Live Table. Talked a lot about constraints. Here's what one looks like. So in SQL, we just say, hey, here's a constraint. We named it valid account open. And we told the framework to expect that we have something in account, have it spelled it right, and the account hasn't been closed. If we violate that constraint, we just drop the row. The pipeline continues processing as normal. And you see in the data quality stats, what percentage of the records were actually dropped. That's all kept track of in a set of metadata tables maintained by DLT that you can then use to build dashboards for data quality measures across your entire enterprise. And you can do notifications. So just like anything else that you're doing with DB SQL, you can turn DB SQL on DLT and create alerting and notifications and logging and things of that nature. And of course, the ETL development cycle is now pretty much automated. So we can do normal CI/CD with Git semantics and then promotion type pull requests and things of that nature. And we can deploy and manage our environments using parameterization. So the DLT definitions themselves accept parameters. So you can actually create a table of values that you would need for each different environment and use the same exact set of code as you promote it through the pipeline. Lots of unit testing and documentation happens automatically, and I can show you a little bit about how that is, and there's a whole lot of really good references on our DB demo site about how to actually do unit testing with DLT. And then, of course, we have this enablement of a metadata-driven ability to programmatically scale to hundreds or thousands of tables and pipelines automatically built into the product. You can choose between a start for an incremental refresh or a full refresh, and you can see the history, how it's been going through the last few runs. Auto scaling will add more compute when you need it, scale it back down when you don't. So even if the individual table creation elements of your pipeline require different compute profiles, DLT is going to figure all that out, and it's going to scale up when needed and scale back when it doesn't. And then, of course, you can integrate this directly with our workflow orchestration. So you can do, DAGs that consist of DLT graphs as well as other types of tasks, and integrate it with Airflow or ADF if that's what you happen to be using for your workflow orchestration. So that's really kind of all the preliminaries in terms of what we need to know to kind of get going on the demo. Are there any questions on that so far? Okay, so what this demo is about is it's based on something that I've encountered in the field a number of times, and that is we have hundreds of thousands of legacy events sitting on S3 in this case, sitting on our block store, and these events could be images, They could be telemetry from an IoT device, truck fleets, things of that nature. In this case, I wanted to simulate the data, and what I did was I took the protein sequence database that is maintained out of Max Planck and the JIP labs, and I chopped it up into individual events. So what I have is I have these hundreds of thousands of small protein events. What I really want, though, is I want a single delta table with all the elements expanded to their level of sensibility. And I'll talk a little bit about that when I have the actual event on the screen. And then what I'm going to do is I'm going to JSONify these objects first, because I'm just super comfortable working with JSON, and the sooner I get it there, the happier I am. So this is what an individual protein entry looks like. And if you can kind of envision this as a, not a static or a batch job, but the beginning of a iterative job where new proteins are arriving, on a daily or weekly cadence. So I have to run this job pretty frequently so that my database contains the most up-to-date capture of the proteins that they're finding out there in the wild. And for my research, what I'm super interested in is proteins that have a classification and that have potentially a feature label, things of that nature. So I'm going to want to, create my gold table based on some constraints to filter out records I'm not interested in. This particular protein came from a California gray whale, and my level of sensibility for expanding these is every top level element that exists as an array. So in this case, say superfamilies, classification. You notice we have repeated superfamily elements. So what I want to see in my delta table is I want to see a classification column that contains arrays of superfamilies, things of that nature. Keywords, same thing. I want to see a keyword column that contains an array of keywords. So that's my level of sensibility. But the good news is if there are others, we can just make different silver tables. But this is where we're going to start today. So where I always start every project is with EDA. So I need to do some data analysis. And in this case, it's pretty easy. What I really want to do is just see, can I do this? Can I make my XML easily into JSON? So this is what we call a pandas UDF. So it's a user-defined function realized in pandas. And the reason we realize it in pandas is because we have a very efficient serialization engine in Spark when we call pandas UDFs. And what I'm doing here is kind of a common design pattern where the actual work, I'm just doing that in a normal Python method. And the reason I do that is because now it's easy to test. I'm doing this where I look at the test, but it's just as easy, and I have done in production environments, to encode the expected output in JUnit type testings or Python unit testing, and do expects with the testing. So this creates a generator, the UDF does, that will then yield all of the JSON elements I need. But first things first, I went ahead and I'm just going to run this while we're talking. I went ahead and tested out, does the JSON record encode the way that I expect? And sure enough, it does. So that's great. So next step is I need to test this logic. Does my pandas UDF work? And the answer is, well, yes, absolutely, it does. So we just ran this. Actually, it took about 2 seconds, just a minute or so ago. And I get a nice JSON blob of a protein entry. But it's got the protein heading entry, so I don't like that. But we'll deal with that in a second. So I know that because I want to explode this JSON content into a bunch of different columns, I'm going to need a schema. Fortunately, there's a method for that. So what I've done here is it's just a little twofold trick. So trick one is I'm going to get rid of the enclosing tag. So I know it's a protein entry, so I just get the things that are protein entries. And then I'm going to grab the schema off the first one using a schema of JSON method. And that gives me the schema, and I just capture that and I put it into a string. Now what I get to do is I get to actually turn it into an array. So from JSON takes my schema and turns it into an array. And this is great, right? This is exactly what I was looking for. All I need to do now is explode this array into columns, and I'm done. So this works once. All I have to do now is do this, 259,999 more times, and I'm done. So this is where we commit to DLT. And while I'm showing you the DLT code, I'm actually going to restart the pipeline with a full refresh all and let it run while we're talking. So for this example, I chose to implement my DLT tables in Python. Could have just as easily been SQL that just happened to, I just happened to use Python today. And it's funny, going back in time, I used to need to create mocks to be able to run the notebook to make sure my syntax was okay, but I don't have to do that anymore. So I'm going to get rid of that because what we have now is this Delta Live Tables button, and I can actually tell it to validate the graph as I write the code. So all I did is I took my function from my exploratory notebook, and I put it here in this notebook. I then grabbed my content schema because I know I'm going to need that, and now it's just time to start defining tables. So this, if we look here, and here it is. So this first table, the raw table, that's defined right here, just by giving an annotation DLT table. I can give it comments, so there's metadata on the table. I can tell you what quality the table is. And I did give it a little bit of configuration. Shouldn't need to do this. Hopefully in the future won't need to do this, but we're still not having super sensible defaults about shuffle partitions. And if we've worked, with this a while, we all know that. So I just sized it at 16. I get a good result with that. And then, yeah, away I go. I tell it I'm reading in binary files because we don't have a native loader for XML. I'm telling it to load it from my S3 bucket. So that first table has now been defined. In the time we're talking, it's actually starting to, you realize there, you see the schema that comes in. So remember, we talked about those raw tables. So the schema that comes in is the content, so the actual binary object that was in the file, and then just a few bits of metadata. I have the path, where it came from, the modification time, and the length of the binary object. So then I'm going to take that and I'm going to create another bronze table, but I'm going to make it temporary. And this is going to be that step where I actually extract the protein entry columns themselves from the JSON object that I get from the XML file. And the reason that's temporary is because I'm going to immediately do something else with it. And the intermediate product isn't that valuable, so I didn't feel the need to store it. If I wanted to store it, I'd just change that to false. And that's this table right here, which is getting ready to be defined. In about 10 minutes, it's going to start running. And then moving on, now we create the first silver table. And that's actually got the array of the protein entry schema. So with that array, I can now do dot expansion and say, give me, protein entry classification, give me protein entry organism. And finally, I can get to the gold table that I wanted, which is I want to look at things that have classifications and came from a critter. I'm interested in organisms and classifications for my science. So I make a gold table. And how I make that is I declare it. I say, give me a table. We're going to call it DLT Skill Builder Gold. And I'm going to just run this select. I'm going to do a splat expansion on the protein entry array column, and that's going to give me everything I need. And while that's cooking, let me talk about two things. So one of the first things that people encounter when they're using DLT for the first time is a little confusion around what's the table. Because if I'm a Python person and I'm looking at this, I'm thinking, okay, I just created a table, but I did not, and that's a very important point. This is a declarative framework. I'm declaring a table. The actual table itself is controlled by and run by and realized by this pipeline. And the Python object, or pipeline object, basically is where you describe the mechanism of building the table, and then when you run it, the table is built and managed. So I just give it a name. I tell it advanced because I want the latest features, and I tell it it's triggered. And this is where I select between what I would call batch and streaming. So triggered is batch. And I can trigger it once a day, I can trigger it once an hour, I can trigger it once every 5 minutes. It's still batch, right? I'm running in batches. Continuous, it just keeps on running. So that's what people conventionally think of as streaming. But remember, as we're processing the data, it's always streaming. There's no difference. The only real thing we need to reason about anymore between batch and streaming is which one of these radio buttons I push. I tell it the source code, and I can select more than one path. And in most of my production pipelines, I do. This happens to have one notebook, so I give it a notebook. In this case, I'm going to tell it Hive Metastore because I want to get to UC, but a lot of us come from Hive Metastore. So I just wanted to, do that and get it going. I tell it the schema that I'm going to write it out to. If there were a cluster policy I wanted to use, I would apply it here. I give it parameters around the minimum and maximum workers. I tell it use Photon because this is writing a lot, and Photon writes are amazing. If I were doing, other, transformational operators that were not in UDFs, I'd also use Photon for that reason, because there's just the vectorization of the standard Spark functions in Photon has been incredible, and it gets better every day. I'm giving it an instance profile because I'm loading data from S3, so I need to have some sort of, authorization to load that data. And then I could, if I so desired, give it a notification. So I could say, send me an email on, success failure, fatal failure, that kind of thing. And I can also give it configuration. I'm loading the preview channel. No real reason to. I'm just, in this particular instance, because it's Hive Metastore, but for UC, I will need to load from the preview channel. So that's all I need to tell it. And I can realize that in JSON, so I can also put my pipelines under CI/CD control, and away it goes. And while that was running, we've processed another 15K or so records, and it'll just keep on crunching through. So I felt pretty good about this. So I thought it was time to move on to Unity Catalog, and I created a pipeline. And this will look really familiar, except it was broken, so I named it broken. And I ticked the box for Unity Catalog. And I told it, put it in my catalog, and put it in a schema called broken demo. Other than that, everything else is the same. And I hit go, and it failed. And the reason it failed is because UDFs aren't supported in Unity Catalog yet. Fortunately, we're in the midst of a preview on exactly that function. So, any day now, and I see a couple of Bricksters on the phone who might be nodding along, forward-looking statements and all that. My recollection is it's coming out in 13 LTS. Please check with your account teams for exact dates. But it's available now as a preview and will be available soon as a public preview and in GA. And when that time comes, what you really need to do to set up the tables is enroll for the public preview, or the private preview rather, and create one additional tag. So Python UDF enabled, and I set that to true. That allows the update to run as expected. And as this goes through the pipeline, we'll get a good result. Are there any questions on that so far? Okay, so in the time we have left, I kind of wanted to show you the output of the table. I'll just show you some sample data. This is my UC table. And because I just launched the pipeline, it's actually, because I did a full refresh, it's dropped the table to create it again. Had I done an incremental refresh, it would have just added to the end of the table. So let me pop over to my DLT demo that has some rows in it. So this is the Hive Metastore table. It's going to be the same schema. And remember, I didn't define a schema. I just kind of defined a table, and I got the schema as a side effect of that. So then you see we have all of the paths, modification, the length, and they're all right around the same length. And then this big binary object that is actually the data itself. So with that, as we're waiting for this to finish, that kind of ends the demo portion. I'd love to open it up to Q&A, and then when the pipelines have completed, kind of show you the result. So is there any questions so far?
There's a question in the chat.
Oh, fantastic. Let me see if I can find it. There it is. Is it the same process? It's actually even easier, Thomas. So there's a web page. Let me go find that web page. And what you can do is either, work with your account team to have this filled out, or alternatively, you can fill out yourself, because it's actually a public-facing web page, and it's right here. So can I put it in my, yes, I can. I'll just put that right in chat. And what it looks like if you open it is just regular Q&A, acknowledgement, and once you hit agree on that, they're actually pretty quick on this one. I've seen it take a day. Over the weekend, it might you might ask on a Friday and get it by end of day Monday, but it's actually really quick. And then when you're added to the preview, they send you the instructions I just talked about. Anything else on that?
All right, so there's a question on if you can use Azure DevOps with DLT.
You can, and we have a whole lot of really good enablement material on that out in the internet. With our first party relationship with Microsoft, we do, I think, a fairly good job of talking about and documenting the integration points. So yeah, absolutely, Azure DevOps and DLT is no problem at all. Anything else? Well, so coincidentally, this thing takes about 12 minutes to run. So rather than sit here in anticipation, I think unless there's any other questions we'd like to discuss, I think this pretty much wraps it up. So kind of to net it out, my experience with DLT has been it's extraordinarily easy to use. It gets people with very little Databricks experience actually into prod in a very short amount of time. And coupled with UDFs, it's just a really powerful capability that I've been using in pretty much all of my production architectures for the last six months or so. So I thank you for your time. And if you have any additional questions, please don't hesitate to reach out, or we can discuss them now.
All right, thank you, everyone. We will be sending out a recording in the next day or so. And thank you for your attention.
Thanks, everybody.